The views expressed on Skeptically Speaking are not necessarily the views of this station, its affiliates, sponsors, or advertisers.
Bring it on, the skeptics await your letter. Your call, tweet, homing, pigeon, whatever. Desiree Shell gonna raise a little hell, metaphorically that is. Cause we're skeptically speaking.
Welcome to Skeptically Speaking. I'm your host, Desiree Shell, and today's episode is tackling aging. Why and how we do it, some of the impacts that aging is having on society, and what we can expect in the future. A little later on in the show, we'll speak to Alex Zhavoronkov, author of The Ageless Generation. But first, let's sit down with Michael R. Rose, professor of evolutionary biology at the University of California at Irvine, and director of the University of California Intercampus Research Program on Experimental Evolution. His main area of work has been the evolution of aging. Welcome to the show, Michael.
Thank you, Desiree.
Now, before we get into it, we should point out that, unlike humans, some species don't age at all, correct?
That is correct.
And how do they avoid that, exactly?
Fantastic question. The short answer is that these are all species in which the reproduction occurs by splitting in two symmetrically. So there's really no difference between the two products of the reproductive act. So the best studied example of this is the simple coelenterate called Hydra, Hydra, which I used to study in my high school biology class in the 1960s in Ottawa.
So I have heard a ridiculous number actually, of hypotheses on what the fundamental cause of aging might be. So what are the claims that you're aware of?
Well, theories about why aging occurs are basically diffused over all civilizations with written records that we have. Some of the oldest stories in the records of civilization are stories about causes of aging and how to escape from aging. So this is, a favorite topic, particularly of elderly male academics, since academia was first invented. The guy I turned to as the first really, really thoughtful person to write about aging was Aristotle. That was about 2,400 years ago. And he wrote a really excellent book on the subject, which readers other than myself in the 1960s considered the best book that had been written on aging up until that date. I think we've made a little progress since Aristotle, but basically Aristotle started a pattern of thinking about aging that almost everyone has sustained ever since. Aristotle told a story about cumulative breakdown in the way organisms work, both plants and animals in his case, and cumulative breakdown stories have completely dominated all theories of aging that have been proposed up until 1996, when a colleague of mine, Larry Muller, and I proposed a completely different theory.
And this theory would be?
Our theory is that aging is not in any way a physiological process, that aging is instead the detuning of what Darwinian biologists call adaptation, and that detuning comes to an end. And when it comes to an end, aging stops.
Okay, can you give us a bit more detail, but not so much detail that a non-evolutionary biologist will be confused?
Sure. Maybe I can start by appealing to the concept of adaptation in biology in general. So adaptation is the idea that, wow, things are working really well because this organism has the attributes it needs to do what it needs to do. So birds fly really well. They have wings, they have air sacs, they have other adaptations, make them really good at flying, and those are called adaptations for flight. All right? Now, up until 1859, there were two main schools for explaining adaptation in Western biology. One was God did it, or creationist theory. The minority theory, which was the Lamarckian theory, is that a physiological process produces adaptation. Then Darwin came along with a completely different theory that was all about evolution by natural selection. Now, you could still say to this day, why do we age? Well, because God wants us to die so that we can join him or her or it in heaven. All right, so that's one theory. These days, not a very popular theory. The other kind of theory for aging is just like Lamarck's theory for adaptation, which is that it's some kind of physiological process that causes us to break down, just as Aristotle proposed really eloquently 2,400 years ago. The problem with all of those theories of cumulative breakdown is that if you look at the death rate at individual ages, not the total dying, because in a sense we all die eventually, but if you look at the death rate, it turns out that there are organisms like the hydra that I mentioned before that never age because their death rates are stable. And there are other types of animals, like Drosophila, the fruit flies that I work with, that show an aging phase at the start of adulthood that comes to an end and stops, and then the death rates are stable just as they are in hydra.
Well, can you tell us about your fruit fly research? Because you've actually provided some evidence for this hypothesis.
Exactly. So our experiments sort of divide into two parts. The first 20 years I spent showing that the idea of evolution being at the core of controlling aging was a good idea. And I've shown that since the 1970s by changing the focus of natural selection so as to make it produce longer and longer lived fruit flies. And I became pretty well known for that work in the early 80s, when I was so young that I didn't care that much. Now, of course, I'm way older and I care way more. And I think, at least among evolutionary biologists, that work is generally accepted. And evolutionary biologists would generally claim that the kind of experiments that I did in the 70s and 80s basically showed that, in fact, it's evolution that controls aging, just like it's evolution that controls adaptation. What's been more controversial is what we've been doing since 1996 on trying to figure out why evolution lets aging stop. So in 2011, together with my coworkers, we published a book asking the question, does aging stop? Because up until the 1990s, no one thought that aging stopped, and that included me. I didn't think aging stopped. But basically, starting in the 1990s, it became more and more apparent from very large experiments that aging actually stops eventually. And explaining why has been lots of tricky fun for my lab.
Well, and one of the things that you've said is that your model is the only predictive model of aging.
The simple way to put it is, ours is the only model where you don't need to invent stories and say, oh, the reason why that experiment didn't work is because, we didn't put the right cells in the solution and so on. The kinds of experiments that we've been doing since the 1970s work really easily and really straightforwardly, no special pleading required, which is what I would call, good experiments that work. And not only that, but it's all based on, I'm sorry for your listeners, very painful math. But the painful math in our field, just like in physics, really works, and it predicts things that no one has ever seen before, so we can then do experiments to test those predictions that no one has ever checked before, and they work.
You're listening to Skeptically Speaking, and this is Desiree Schell talking with evolutionary biologist Michael R. Rose. So all of the research that you've been doing, controversial as it may be, and quite honestly, I keep my finger in aging research because I find it fascinating, but it is considered fringe. So could this research be applied to humans, realistically?
The surprising answer is yes. It surprised me. It's only in the last few years that I realized that there is a human application of this idea. It's fairly hard to explain. I'll give it a go. The basic idea is that if natural selection is basically the force that tunes the aging process, which I argue my research shows, other people might dissent, but if you grant me that premise, the problem with natural selection is it fades out with age. That creates an additional problem for species that have undergone a change in their lifestyle in the course of their recent evolutionary history, which is exactly what humans, in fact, have done. no one disagrees that the story of recent human evolution is that up until some 5 to 15,000 years ago, we were predominantly a hunter-gatherer species. There was a little controversy as to how much we hunted, but some hunting definitely went on. And then we changed our lifestyle very much to adopt agricultural foods. Now, some of your listeners have no doubt heard of the paleo movement, which is based on the idea, no, we should never eat agricultural foods. And I'm not going to support that story. What I'm going to say instead is that our research suggests that humans at a young age are in fact very well adapted to eating an organic, healthy agricultural diet with lots of whole grains and all that good stuff that Andrew Weil would recommend to you. But that at later ages, in your 40s and 50s and beyond, you lose your adaptation to the agricultural diet and you revert to a physiology that is better adapted to our ancestral hunter-gatherer diet. Now, that's not just a little verbal story. That's also derived from some pretty hardcore math, which is in our book, Does Aging Stop? It's also stuff we're testing experimentally because in our lab, we actually inadvertently did an agricultural-like experiment where for the last 1,000 generations, we kept our flies on a completely new diet, which we think of as like the recent agricultural diet in the sense of the evolutionary story. And before that, they had a very different diet. And if we check how well they're coping on their long ancestral diet, we think we can supply experimental evidence for the basic theory I just conveyed to you.
Now, is this getting into calorie restriction? Because I know that's very closely tied to the anti-aging field.
No, it is not.
Okay.
It has to do with what kinds of calories are you going to consume, where are they going to come from. There is almost certainly some small effect in terms of benefit for your survival rate if you undergo a lot of caloric restriction for a long time and are willing to accept being pretty skinny, not necessarily frighteningly skinny, and have a diminished sex drive, diminished cognition, and so on. I published a paper with Jay Phelan of UCLA arguing that we might get as much as 2 or 3 years of additional life from 20 or 30 years of a lot of dietary restriction. If that's worth it to you, then great. I have a different proposal now that if you qualitatively shift your diet when you become middle-aged, that you might get much greater health benefits than you would get from caloric restriction.
Let's go this way, because I am a layperson, and the vast majority of my audience are lay people. So what would you say are the best arguments against what you're claiming?
Well, I would say the best arguments against what I'm claiming is that the pop paleo diets that lots of people are now pushing all over the internet, lots of reasonably selling books, haven't really given anybody really dramatic health benefits. And firstly, I say, well, if you try this when you're in your 20s or 30s, which is a very fashionable age to try it, especially among athletes, I don't think you'll get a lot of benefit from it. I think the benefit is really best for geezers like myself, my friends in their 50s and 60s. And when I persuaded them to try it, and they have in fact tried it, they get pretty substantial health benefits. But I should say that when you say that, or precisely when I say that aging stops, that doesn't mean you suddenly become young. It means you don't continue to disintegrate. It means you stabilize. It doesn't mean that you can't get heart disease. It doesn't mean that you can't get cancer. You can still get all those things. It means that your rate at which you get all those things doesn't shoot up into the sky. So I'm not saying that if you follow my dietary advice, which is in the book Does Aging Stop, and on a free website called Michael Rose's 55, that's numeral 55, I'm not saying that you will suddenly become young. I'm saying that you'll hang on in relatively mobile geezerdom. That's all I'm saying. So I'm saying, you can still, to your university professor, toddle off to your classes and proceed to bore lots of young undergraduates who are not impressed with how smart you think you are. I'm saying that you can continue to drive your car and do really basic tasks. I'm not saying you will become an Olympic athlete. at the age of 62. So what I'm proposing and offering isn't really that dramatic. It's a way of making the last decades of aging a little less brutal.
Have these kind of experiments, on older people following the kind of diet that you're prescribing, have they been done at all? Is anyone doing those perchance?
Well, lots of people are doing them informally. My work, as a scientist, is to test these ideas as completely general ideas. So, I work with fruit flies. Fruit flies have been the most important organism for figuring out things like genetics, cell biology, neurobiology, and so on. They're a really mainstay of biological research. And our hope in our lab is that if we can make progress in addressing the basic idea I've just sketched for you in fruit flies, then maybe we'll reach a point where we can persuade the cell biologists who would like to inject you with lots of brand new genes that maybe there's a less drastic way to proceed.
See, the problem with this is, as a layperson, it is very difficult for me to give more weight to any particular anti-aging hypothesis because I just don't have the background to assess them. So what is your advice for people like me? How might we be able to distinguish, between cutting-edge research, which is fairly fringe to begin with, from the truly ridiculous?
Thank you, Desiree, for asking that question. So your first step to differentiate real quackery from academia is to go to Google Scholar and type in the name of the author who's telling you that all you need to live forever is to eat nothing but broccoli, and check how many times over a number of years their colleagues have cited their work. And if that's only recent or relatively small, then probably you don't need to take what they have to say very seriously. The second thing you could do is look at the institution they're at, as what be they regular faculty in the case of universities, or if they're employed by NIH in the United States or the Wellcome Trust Foundation in England. You can get a sense of their disciplinary credits or credibility. Those would be your two basic tools to start with.
That is very helpful. So I guess the other issue is that those of you who work within the anti-aging field are pretty starkly divided into two camps. Those who think that some kind of anti-aging breakthrough is right around the corner, and then those of you who think we still have a long ways to go. So which are you, sir?
Both or neither. Your listeners should understand that unlike most people who talk about anti-aging, my whole livelihood as a professor, which I've been since 1981, has been based on my success at controlling aging in a lab. So unlike almost everyone else in the field, I have had no problem very substantially increasing the lifespan of the organisms that I work with. That's, I guess, your third way of differentiating, the wolves from the sheep, from the pigs, or whatever other animal farm cast members you would want to use. Some of us, like myself, have actually produced organisms that live much longer. And really, we're the only people who should be listened to seriously because we've actually had some success. Now, all of my success over my career really has been with fruit flies, Drosophila, which your readers might think, well, who cares about fruit flies? And Jay Leno once made a joke about my research on The Tonight Show. Well, why should we care about fruit flies living longer? Well, as I tried to say earlier, fruit flies are where we first figure out how things work in animals, be they genetics, neurobiology, even now heart disease is being studied in fruit flies. Fruit flies are our go-to guys, if you will. So I don't think I need to be too apologetic about, all my good data coming from fruit flies.
No, I think that's fairly realistic, everything you've said. Thank you. Because I am very, very interested in this field, but as a layperson, it all just sounds so fantastical to me that it's difficult to differentiate.
Well, your problem is only compounded by the fact that biology is going through a complete revolution. And stuff that was perfectly respectable, that I myself believed in 15 to 20 years ago, is now being hung out to dry and wiped out. So, of course, it's very confusing. It's a time in biology very much like what happened in 1900 after the rediscovery of Mendel, and suddenly biology became based on genetics and experiments, which it hadn't been before. Right now, biology is being based on fairly powerful quantitative theory, or at least it's being reformulated in terms of powerful quantitative theory and genomics. So one very common point of view offered by the cell biologists and molecular biologists who work on aging is to say, I have discovered the key to aging, and it is in this particular biochemical pathway, because when I mutate that particular pathway in my lab, the organism dies really fast, or the organism lives significantly longer. So many biologists now claim, characteristically, that their single favorite pathway is the cause of aging. And in many cases, I think they're almost all right, because they have identified sort of part of the elephant. I think there are many different cell molecular pathways responsible for aging, and the basis on which I think that, we published in an article in Nature in 2010 where we show the genomics that control aging, and it turns out there are many sites across the genome, admittedly again in fruit flies, which in fact are responsible for building the kind of longer-lived fruit flies that I've studied in my lab for almost 40 years.
Thanks very much for being here. That truly was helpful.
Good.
You can find a link to Michael Rose and his research on our site at skepticallyspeaking.com. And we'll be right back with Alex Zhavoronkov, author of The Ageless Generation, after this.
Skeptically Speaking is rebroadcast on a number of fine radio stations. To find out where Skeptically Speaking airs near you, to listen to past episodes, or download the weekly podcast, check out our website at skepticallyspeaking.com. While you're there, follow the links to connect with us on our Facebook page, our Twitter feed, or to subscribe to the show in iTunes. And now, back to the show.
I'm here with Alexander Zhavoronkov, Ph.D., Director and Trustee of the Biogerontology Research Foundation, a think tank supporting aging research worldwide, and the founder of the International Aging Research Portfolio, a curated knowledge management system for aging research. He's also the author of The Ageless Generation, How Advances in Biomedicine Will Transform the Global Economy. Hello, Alex. Thanks very much for being here.
Hi, Desiree. Happy to be with you.
Now, maybe we could start out. Could you paint us a picture of what the current ideal retirement is? Because in your book, you refer to it as sort of American dream retirement.
Historically, retirement was dependent on the person's physiologic condition. Many centuries before, people were reliant on their families to support them when they lost function. In 1880s, the situation changed by Otto von Bismarck, who introduced the notion of social security. When a person reached a certain age, the government was to provide for the person. He pegged the age of retirement to 65. Very few people at that time lived to that age. In 1930s, the US adopted a very similar system and also used 65 as the target retirement age. So after that age, the citizen was entitled to Social Security, which included pensions and various benefits. In my world, the concept of retirement does not exist. I believe that people should be pursuing the path of lifelong learning and lifelong career planning. And that would be the ideal retirement. The ideal retirement would be the shift of careers constantly and by the person's ability to perform useful work and by the interests.
So this has a lot to do with the fact that we are living longer now. This wasn't necessarily as much of a problem previously.
Absolutely. Previously, again, at the onset of the 20th century, life expectancy in the United States was just around 50 years. And nowadays, it moved to almost 80. So life expectancy is basically the average age to which a person is expecting to live at birth. There is a major difference between life expectancy and health span. So health span is the person's ability to perform useful work, and it's essentially a measure of productivity, and loss of function. So whenever a person is unable to work and is disabled, that would decrease the health span significantly. So nowadays, the health span has also increased, and people are working into their 70s or even 80s and are as productive as the younger generations. So basically, there is a difference between lifespan and life expectancy, and a difference between life expectancy and health span. And those three variables define the state of economy nowadays. We're actually working on a paper where we measure life expectancy by country, look at the future of life expectancy by country, look at the productivity of labor, and look at how the rate of increase in health span affects the economy of the country. So we are hypothesizing that the increase in health span is the new economic driver contributing to the growth of economy of a country.
Well, there's also there's a decrease in the birth rate as well.
Every developed country with higher life expectancy has decreased birth rate. So in Japan and Taiwan, in some of the developed Asian countries, we see birth rates where the population is on decline just because the birth rates are extremely low. In order for the population to grow, we need to see the birth rate of 2.2 children per woman. And in countries like Japan and Taiwan, that's less than one. These countries will rely on immigration and robotics to keep the economy going. So if you look at Japan today, you see that the economy is definitely far from perfect. The yen is devaluating. The economy has been on the decline over the past 10 years. It's been in a recession. Despite the rate of technological acceleration and despite the very well-developed manufacturing and technology segments. So we drive Japanese cars, we use Japanese cameras, we use Japanese computers, but unfortunately their economy is declining. So that is partly attributed to the increase in the number of retired citizens and the increase in life expectancy. So Japan is one of the reasons why Japan is facing an economic crisis right now is the shift in demographics. And that's going to get only worse.
Well, and that's not just Japan, is it? This is, you say in the book that seniors programs are the fastest growing and largest line item in budgets of most developed countries?
Oh, absolutely. After Japan, the second region to look at would be the European Union. In the European Union, the economic condition is not much better than in Japan. In certain countries where the retirement age is in the mid-50s for women, for example, Greece, we see that the economy is doing much worse than even in Japan, primarily because of the social sector development, where seniors, after reaching a very young retirement age, receive enormous benefits compared to many other countries. So in the United States is probably more resilient to those demographic changes, primarily because the citizen is partly responsible for retirement planning. So the citizen is expected to save during a lifetime and plan for retirement. So about only 30-something% of the total retirement benefits come from the government. However, what we did recently, we published a paper in Pensions International Journal where we looked at several scenarios for mortality decreases in the United States and looked at how those mortality decreases will impact the economy in the United States. And even a marginal decrease in mortality due to the improvements in healthcare and biomedical advances reaching the clinic results in a very major increase in unfunded liabilities of the country. So currently we see a lot of discussion about the $16 trillion debt, public debt, that the United States is trying to cap. However, if we look at the liabilities that the country has in front of their citizens, to their citizens, we're talking about social security and healthcare, it's already topping $80 trillion. Even if we're taking a very conservative assumption of the life expectancy around 80 years old.
You're listening to Skeptically Speaking, and I'm joined by Alex Zhavoronkov, author of The Ageless Generation, How Advances in Biomedicine Will Transform the Global Economy. So let's step back a bit. What is aging exactly? Because we know it when we see it, but what is it?
The aging process is very complex, and it occurs on many levels. It occurs on the levels of molecules, it occurs on the levels of cells, it occurs on the extracellular level, on the tissue level, on the organ level, on the organismal level, and even on the psychological level. So in order to better understand the aging phenomenon and understand the current efforts that are made in either studying the process of aging or identifying the remedies for aging, we created a resource called the International Aging Research Portfolio, where we look at biomedical grants as the major source of innovation in biomedicine. And we created over 300 of various categories that relate to aging and classified them into two major categories, so natural sciences and social and behavioral sciences, and then created a large taxonomy of categories underneath these two main categories. And we are trying to understand the complexity behind aging and look at the main causes. So again, there is no single reason behind the aging phenomenon. There is a very large variety of factors that affect the rate of aging and age-related diseases. Many scientists in our area are already trying to treat aging as a disease because, again, it leads to disability and loss of function. There are lots of different theories. There is no unified theory of aging. But
That's what I was wondering, because there seems to be not a lot of consensus around a lot of this research. Would you agree?
Absolutely. There is lack of consensus in this area of science, and that's primarily because there are many scientists studying small aspects of aging. The notion of the systems biology of aging is very new. Before, when you were studying oxidative stress, you could say that I'm studying oxidative stress and its relationship to aging disease, and I believe that oxidative stress is the main cause. Nowadays, at least what the industry agrees to is that the aging is not caused by a single factor, and it is not programmed. It is caused by a very large variety of factors, and it's the interplay of those factors that affects the rate, that defines the rate of aging. But what we are really interested in is how aging affects the loss of function and how it prohibits us from doing productive work. And factors that lead to the loss of functions that are age-related, that would be the loss of motor neurons, that would be cognitive decline, that would be pain, that would be decline in immune functions, vision loss, loss of renal functions, it would be obesity, metabolism, it would be sarcopenia, it's the loss of muscle mass, it's loss of bone, it's the cardiac dysfunction, and the mineralization of connective tissue and the formation of the advanced glycation process. And I can go on and on and on. There are many factors that affect the loss of function that are related to age. And in every area of science that I've just described, there are thousands of scientists working towards finding cures for those diseases and those factors contributing to aging. So that is why it is very difficult to reach a consensus, because there are so many contributing factors. And there are very few people that are looking at the systems biology of aging. So when I started the project Aging Portfolio, one of the problems that we faced was the lack of a taxonomy for aging research. So there was nothing out there that had any kind of roadmap or any kind of classification scheme for aging. So we had to develop our own, and we're one of the first ones to do that. At every conference you go to that touches aging, people are just starting to talk about roadmaps. They're starting to talk about the interplay of various processes and ways that we can explore to systematically approach aging. So currently there is no consensus, but there will be a consensus within the next 5-10 years. We will understand this phenomenon better. One of the projects that my team is working on is called the Aging Chart, and it's basically a Wikipedia of aging. We're trying to create a very visual, pathway-oriented system where anybody can go in and either take a look at the diagrams that create a cause and effect relationship of various processes that occur during aging or that cause aging or result from aging, and can edit in the Wikipedia mode any of the diagrams and then discuss it with the peers.
This is Skeptically Speaking, and I'm talking with Alexander Zhavoronkov, author of The Ageless Generation, How Advances in Biomedicine Will Transform the Global Economy. And we'll be right back after these messages.
On the next episode of Skeptically Speaking, we're looking at some of the less desirable effects of global trade and market economies. We'll speak to Mark Harrison, Director of the Wellcome Unit for the History of Medicine and Professor of the History of Medicine at Oxford University, about his book Contagion, How Commerce Has Spread Disease. And we speak to Nora Chek, Professor in the Department of Economics at the University of Bamberg, about her research into the ways that markets influence moral decision-making. That's next week on Skeptically Speaking, on your local radio station, or online at skepticallyspeaking.com.
Welcome back to Skeptically Speaking. I'm your host, Desiree Schell, and my guest is Alex Zhavoronkov, the head of the Regenerative Medicine Laboratory and the senior research scientist at the Bioinformatics and Medical Information Technology Laboratory at the Federal Clinical Research Center for Pediatric Hematology, Oncology, and Immunology, and I deserve a prize for getting through that. He's also the author of The Ageless Generation. So before the break, we established that there's a ton of research going on, which is lovely, but there's another side to this. Your book actually provides a lot of other solutions to these kind of problems we're dealing with in regards to aging. So what exactly are you proposing? How should we be dealing with all this?
First of all, we should take a step back as policymakers, as people, as scientists, and take a look at the history of science and humanity over the past 500 years before we can ask these questions to ourselves. So what happened over the past 500 years is that, well, first of all, the population has increased dramatically. So if we look at the 1400s, the population was just over 500 million people inhabiting this Earth planet. And nowadays it's over 7 billion. But if we look at the rate, how we got there, it took us 400 years for the population to double from 500 million to 1 billion. Then it took us another 160 years for the population to double from 1 billion to 2 billion. And then the last 60 years, we saw the population over tripling from 2 billion to 7 billion. It's more than double, it's more than triple. And the last 60 years brought us more technological advances and more advances in biomedicine than the whole history of humanity. So we really need to understand and realize that things are going to be different when we look at the future than they were before. We are going to be living longer than our grandmother and mother. We're going to be living much longer than thousands of generations before us, and we are going to enjoy a higher quality of life. So if we look 200 years ago, the English Queen enjoyed less benefits than you are enjoying in your daily life today. We're looking at the running water, basic running water, hot water, electricity, the ability to communicate, the access to fresh fruit year-round, access to easy travel, cost-effective communication. We're talking about the paradigm shifts in the literature, in poetry, and music, and everything. So everything changed. And this pace of technological change is probably going to accelerate. And we're going to see the major acceleration primarily in the area of biomedical sciences. So the past 60 years also gave us a very new population group in a society, and that's a population group of people over 65. So in the very near future, it's going to be over 20% of the total population. So today, it's already around 10%. And we really need to realize that things are going to change, that our horizons are going to shift within the very near future. So if we take an umbrella view and look at those last 60 years, we really will see that we need to make radical changes in our social security and pension systems, and of course the healthcare system. Because with this population growth and this number of advances in technology and biomedical sciences, the economies will not be able to sustain a very large number of retirees that are living past 100. What is interesting about biomedicine is that unlike information technology, discoveries that are made on the laboratory level take decades and sometimes many decades to mature and to progress into the clinical use and later into clinical practice and mainstream adoption. And some of the discoveries made in the 1990s are still on the preclinical level or going through the clinical trials. So some of the technologies like siRNA, various telomerase discoveries, various discoveries in gene therapy, they're still not even close to clinical use. We see some successes in terminally ill patients and in certain syndromes, but we don't see clinical adoption. When those technologies are going to hit the market, life expectancies worldwide are going to jump dramatically. And what happens to the people that are already retired? They are going to be living longer and drawing social security and healthcare benefits from the economy without contributing much to the economy. So they are going to outlive their savings, and they're going to be outliving the capacity that the economy has to sustain those retired generations. So, and what are we going to do then? So, if we reach that point where we really need to cut down on those expenses, some people are going to be devastated. So, proactive steps need to be taken right now to already account for advances in biomedicine that will reach the clinic. So we really need to plan ahead and peg the life expectancies to much higher numbers. So we need to proactively increase the retirement age ubiquitously. It's not only in the United States and other developed countries, but ubiquitously, and prepare the population for living longer, for longer life, for the need to work longer. And as a matter of fact, it should be good news because life expectancies are going to increase. They are going to enjoy life longer. They have more time to spend with their kids. They have more time to engage in their favorite hobbies and activities. It's a positive thing.
This is where I think that maybe this is where this whole theory falls down, because I know older people, and I would like to know how you're going to sell to people that it is an attractive proposition to forego retirement, because people have been working for a long period of time, sir, and they have been told very clearly that they are done when they're 66 now in Canada. So how are you going to sell that?
Well, again, the concept of retirement is reasonably new. It's just over a century old. So, unfortunately, people get used to good things rather quickly. Just like if we look at some of the civilizations that have collapsed, like, for example, Roman Empire, people get used to a certain lifestyle and they are not able to adapt to change. And you see a major collapse in the economy that then causes decades or centuries, in some cases, of the need to repair the damage. So you get a major pushback. So we need to act proactively to change the retirement age and the perception of retirement in the elderly, and especially in the generations that are due to retire in the next couple decades, because those are the generations that will affect the economy most. Because the generations that are already retired, there is very little we can do about them right now. They're already receiving social benefits, and as a matter of fact, it's very unlikely that the older generations will be able to get the first-hand access to some of those technologies that will extend life. Also, some of those technologies need to be utilized in the earlier age in order to give the maximum benefit. So, of course, many of the currently retired and retiring people will be very resilient to this change. But this is a necessity that we need to make in order to avoid a much grander economic collapse and a global economic decline. Because nowadays, globalization made it very difficult for just one country to close the borders and do something about the economy in a closed mode. Any country that will experience problems will create turbulence in the global economic conditions. So every country must look at proactively increasing the retirement age. It can be done in a variety of ways. Again, in the book, I presented it in very high detail and provided many strategies on how it is possible to increase the retirement age without causing major unrest in the population. So part of this program is educational. So we need to explain to the general population why they are going to be living longer. They need to believe intrinsically that life expectancy is going to rise. We need to make role models of people that are living longer and are expecting to making a plan to work longer. We need to make role models of scientists that are trying to change the general paradigm and trying to extend the healthy working lifespan by producing those advances. We need to encourage the clinical practices to popularize life extending and workspan extending procedures. We need to change the psychology of retirement and basically work from top down and bottom up. So from top down, that's we're talking about policymakers making those radical policy decisions and extending the retirement age much faster than the recent trends in life expectancy, just to be a little bit more proactive about changing the retirement age. Secondly, we need to create centers for lifelong learning and lifelong career planning. So we need to ensure that people that are retiring today have access to education and various procedures to increase their health span, access to preventative medicine, in order to be able to work longer and sustain their skills and refresh their skills. So there are many ways to do that. Well, one way is to have mandatory senior education. So what we have as a mandatory high school education, we need to extrapolate that into seniors and mandate a course or two every couple years, or let's do it in increments of 5 years, 10 years. It's up to the policymakers to decide. There are many success stories that I'm explaining in the book. For myself, I did the following. I basically looked at the current advances on the lab level, looked at the risks, and pegged my life expectancy to 140, 150 without considering the fact that we're going to have new advances on the laboratory level. I'm just considering the advances that have already made and that are going to reach the clinic within the next couple decades. So it's up to the government and up to the individuals to extend those horizons. So for myself, I don't see any greater priority in life other than extending a healthy lifespan in the population in order to avoid the crisis.
Don't you think it might be easier to just find a cure for aging?
Again, the way I see the situation is that we are definitely going to find a solution for aging within the next few decades. It's very difficult to speculate on exactly when, but it's definitely going to happen. We already solved the aging problem, if you think about it, because we already got onto the exponential path of accelerating returns in technology. And the longer we live, the longer we are going to live. However, there is a chance that this increased lifespans within the next 30, 40 years will put such a significant strain on the developed economies like Japan, Europe, and the United States that there is going to be a collapse. And there is a chance that just the economy is going to put the end to biomedical research contributing to our understanding of the aging phenomenon and the ability to combat that process. So that is why it's incredibly important to reprioritize everything you do. So if you were planning to support an effort in climate change, well, that's going to hit us maybe in 100 years. But if we increase life expectancy significantly over the next 30 years and see the economies collapse by the weight, under the weight of the retirement and healthcare systems, all your efforts in climate change are going to go to waste, primarily because governments will not be able to sustain any of those funding programs and maybe even return to coal. They will ignore all the altruistic efforts and go into the survival mode. So all those efforts are going to be wasted. So right now, the major priority is to accelerate aging research, propagate that into clinical use, and extend the healthy working life of the population that is due to retire within the next 10, 20 years, just to ensure that they do not cause that enormous liability that myopic governments are ignoring, and probably are not even ignoring. They cannot envision this process because most of the progress is happening on the laboratory level. So it's incredibly important to reprioritize research in order to fund science that targets loss of function. And I'm talking about both natural, social, and behavioral programs. So because we really need to change people's psychology as well and re-educate them and continue educating them throughout their lives, very long lives nowadays. And it's incredibly important to change the funding landscape that we currently have in science. So one of the major bodies that is funding science is the NIH, is the National Institute of Health. That organization is funding scientists in the US and actually worldwide with over $30 billion annually. A very large chunk of that, almost 30 billion, is spent as grants. And if you start analyzing those grants, you see that most of them are going into either supporting old work, so projects that are multi-decade clinical programs that take a very long time and are not target-based and sometimes failed. So a very large chunk of that money is going to support, going on supporting something that's already legacy. It's not new research. A very large chunk of that money is being spent on programs that do not have health span in mind. So Aging Portfolio, the system we've developed that tracks aging research, we track almost $1 trillion on biomedical grants over the past 20 years. And I can tell you that a very small percentage of that, less than 10%, is being spent on aging research or aging-related research, and less than 10% of that is being spent on research that is facilitating the increases in health span rather than lifespan. So it is imperative to change those priorities in funding biomedical sciences in order to avoid the economic collapse. And also, countries like China, for example, China announced a program of $308 billion over the next 5 years to be invested in biomedical research. It's a huge amount of money. It's 5 times more than the NIH spent over the past 5 years. And the thing is, if the Chinese decide to follow the NIH paradigm, if they decide to go on the same route, we're going to see an increase in science, and we're going to science output, and we're going to see increases in life expectancy and health span, but it's not going to be enough to save the economy from collapsing.
Alex, very good to have you here.
Thank you, Desiree.
You can find Alexander Zhavoronkov and the Ageless Generation at the link on our site at skepticallyspeaking.com. And since you're there already, maybe click the links to Twitter, Facebook, and Google+, so that you can stay up to date on show news. Or you could keep clicking to iTunes, where you can subscribe to the podcast, listen to past episodes, or leave a review. Thanks for listening, and we'll see you next week on Skeptically Speaking.
Bring it on, the skeptics await your letter. Your call, tweet, homing, pigeon, whatever. Desiree Shell, gonna raise a little hell, break the spell of Pavlov's spells. Cause we're skeptically speaking, our mind reading tarot cards and witches, psychics, and their spoon-bending mind tricks. All the humbug, flim-flam, frauds and shams, the charlatan woo. I don't think you understand, it's the hocus pocus, out of focus locus, eroding the brain, making gains on the hopeless. Let the crystal ball fall, smash on the floor, leave the pieces alone, we don't need them anymore. Just a microscope, telescope, magnifier, reading in between the lines of these lies. Bring it on, the skeptics await your letter. Your call, tweet, homing, pigeon, whatever. Desiree Shell, gonna raise a little hell, metaphorically that is, cause we're skeptically speaking.
Skeptically Speaking is produced and distributed by Suburban Panic Media. Our guest coordinators are Rochelle Saunders and Ed Haynes. Our social media manager is Chelsea Butler. Helen Quivalon is our publications coordinator. Ryan Bromsgrove is our production manager and assistant editor. Josh Witten is our researcher. The show is edited by K.O. Myers. Our theme song was written and recorded by AOK. And I'm your host, Desiree Shell.